the
Okay.
basic idea about the derivative and its tangent. So for example, this is xy plane. We have a kind of function here, and if we are talking about its tangent at this point, okay, then tangent is a curve which will intersect only at one point, and it will pass through the line, and it is intersecting at this point. And if we have to take the normal at that point, the normal at that point will be perpendicular to the tangent. Okay, this is tangent,
Okay.
and this is normal. Okay, so for example, if we are given with a function, let's say y equals to f of x is a function, and if I take its derivative y prime, which is f prime of x, this will give me the equation, a function. This is basically the tangent equation, a tangent function, and if I have to calculate it at some particular point a, so y prime at a is f prime of a, that will give me the tangent at that point or the slope. Okay, and then after that what I have to do to find the equation, we know, because tangent is a straight line, and we can take help from the equation of the line y minus y1 equals to m into x minus x1. So from where we can get m1 and x1. m1 will be the slope that we will get from this step. Okay, and what would be our x1, y1? Um,
Very confused, sir.
hmm?
I'm very confused. So if you derive both the derivatives
Hmm.
as equal, you get the slope.
Yeah,
Okay.
yeah, yeah.
And
I
then
think,
you can use the M formula to
yeah, this
find
is
the
slope.
point.
This is the slope now. No, no, we can't use this for to find the point. We will use this formula to find the equation of tangent. Okay, this is for
Okay.
equation of tangent. We will use this for. This is for that. Okay, this is not.
Okay.
This is what it is. It is simply the equation for line. What I am telling you, we are given with some point x1. Okay, we will substitute x1 directly in our function f of x1. That will give us y1. Okay, we will substitute all the values here, and we will get our equation. Let me give you the example. We are given with this question. It says that find the equation of the tangent to the curve y equals to negative 2x squared plus 3x at x is equals to 1. So the equation we are given is y equals to negative 2 x squared plus 3x. Okay, let's take a derivative. So y prime, before that, let's multiply negative 2 with both of them. Can you please stop right now? Just give me, let me solve one or two questions, then I will give you some homework. Negative 2x squared. Okay, I'm not taking
Okay.
the, I'm just applying the distributive property right now. Negative
Oh,
2,
okay.
negative 2x squared, and negative 6x, right? Now let's take its derivative, y prime. So it will become 2 will be in the beginning. So the derivative of x squared is 2x, and derivative of negative 6x is negative 6. So the derivative will become a negative 4x minus 6. Is it clear?
Yeah.
Okay. So now I have to calculate slope. So slope is basically, um, we have to calculate the slope at 1. So what I will do, I will just substitute. x equals to 1 here in my derivative. So if I substitute 1 here, I will get negative 4 times uh, 1 is negative 4, negative 6, and the answer will become negative 10, right? So the slope at 1, x is equals to 1 is negative 10. Okay, now I am given with the equation y minus y1, that is equals to m into
M of X. Yeah.
x minus x1. I can choose x1 as my point, and then I have to calculate what is its functional value when x at x1. So for this purpose, I will just substitute 1 here. Okay, so y1 will become, it is basically the value of x at 1. So negative 2, 1 square is 1 plus 3. Okay, so it will become negative 2 times 4, which is negative 8. All right.
Okay.
Okay, so let's substitute the values here. So y minus negative 8, that is equals to negative 10 into x minus, the value of x1 was 1. Clear?
Yeah.
So it will become y plus 10, y plus 8, that is equals to negative 10x plus 10, right? And after further
Yeah.
simplification, I will get y minus 10x plus 2. So this is the equation of, it is the tangent at point, the equation of tangent at x is equals to 1. Okay. So what's the main reason why because we are not having a linear function. The function was non-linear, so its tangent at any point will be changed. Okay, so its tangent will change, that means its slope at any point will change. So if we have to calculate it at 2, so what you just have to do, you will calculate what will be its slope at 2. So you will substitute, replace x with 2, you will get a
I
different
will
slope.
get the Y.
You will get y at 2, right?
Yeah.
So you just have to substitute that value of y here, 2 here, and simplify it. You will get the equation. Simple, so simple. Okay. I think I will give you the chance at question number 4. You have to do
Okay.
question number 4. Let me solve question number 3 now. In question number 3, we have to find the equation of the normal to the curve at x is equals to negative 1. Now keep the basic definition in your mind. What is normal to the curve? Normal to the curve is basically perpendicular to the tangent, right? So how can I get the perpendicular? So if I have to get the perpendicular to the tangent, I have to find an equation which would be perpendicular to the tangent at that point. So how can I get that slope? It would be, it can be obtained by using that result. If two lines are perpendicular, then product of their slope is negative 1, right?
Yeah.
It is the same formula that we learned in when we were learning about equations, right? Parallel and perpendicular lines at that point. Okay, so let's take the problem. It's y equals to x minus 3 over 3, sorry, over x. So first of all, um, let me break the LCM, so it will become and 3 over x. Any question?
No.
Okay, let's apply let's take the derivative. Derivative of 1 is 0, right? 3. And what is the derivative of 1 over x? It is, just write it here. It is 1
Minus
over,
1.
no, no, it's 1 over x. Okay, I can write 1 over x as x raised to the power of negative 1. So when I apply its derivative, negative 1 will become in the beginning and x raised to the power of negative 2. So it is negative 1 over x squared.
Oh yeah, oh yeah.
Sorry. Okay. So it's negative 1 over x squared. Got it? So y prime will become negative and negative, and they both will multiply. I will get 3 over x squared. Is it clear?
Yeah,
Okay. Now um, I have to check the I have to make the equation of the tangent at x is equals to negative 1. So let's calculate your derivative. To calculate the slope, um, I have to substitute x to be negative 1 and its square, so it will become 3, right? Is it
yeah.
clear? Okay, this is the slope of the tangent line, not of the line which would be perpendicular to it, right? So how to get the slope of the normal?
Multiplied by opposite, inverse it.
So it would be negative 1 over 3, right? Negative reciprocal actually, the slope. Clear?
Yeah,
Okay. Now just the next thing that I have to calculate is the value of the function y1, which can be calculated if I have to substitute negative 1 at the place of x. So negative 1 over 3 x will be replaced with negative 1, right? So it will become negative plus 3, which is 4. Is it clear?
yeah.
Okay. So what is my equation? Y minus y1 into m into x minus
X1,
x1. So y minus y1 is 4, and the value of m is negative 1 over 3, and x, and the value of x1 is negative 1. So it will become y equals to negative 1 over 3x negative 1 over 3 plus 4. Is it clear?
yeah.
Okay, so equation will become negative 1 over 3x plus 12, so it would be 11 by 3, right? So this is the equation of the tangent at that point. Any confusion?
No, sir.
Okay, that's good. Okay, um, let me just write this down. Okay, I think I can see. So please solve question number 4. Can you please change the color of your pointer? It's not visible. Yeah, and you have
Hamza,
to
it is.
you also have to explain me.
Okay.
Yeah.
So we gave a equation, an x cube equation, and they're asking us to find the tangent at x is equals to plus or minus 1.
Okay.
So first we need to find the derivative of this equation to find the slope of that line. Let's say this is it, and
Okay.
that's 1,
Hmm.
this point.
Okay.
Uh, this line over here, that is the derivative of this equation.
At one.
Yes.
Okay.
So the derivative will be 15x squared
Can you please write y prime also? Okay.
24x minus 7.
Okay.
That's the equation. And it's not a straight line this time. It's the curve.
Yeah.
Okay. So we substitute x equals to 1.
Mhm. This is basically a function. No?
Yeah.
We have to get the tangent or the slope. Slope is basically is a straight line. Okay, it is a function. That function models. I will say it models the slope. Okay, that means at
Okay.
any point if I substitute the domain value, it will give me the slope at each point.
So do I take a derivative of this again?
No, no, no.
Okay. Because it's a squared function.
What I told you, it is not a derivative. Oh, sorry, it is a derivative. It is not the slope. The basic definition of the tangent is this. Okay, the equation that we will get, the tangent equation, that equation will represent this equation. Okay, we are
Okay.
getting this equation. What you get, you model the slope of this curve in terms of a function.
Yeah.
Okay, so whenever at any point, now you can see at this point its slope will be like this. At this point the slope is different, so we modeled it. Okay, and now at any point if we have to calculate, we will just substitute that point. For example, in your case you have to check it at positive and negative one, so you will substitute both
So I
points in
don't need to
this.
do any of this. Okay.
Yeah, still there is no need of this. What I am from.
Yes.
This is basically slope.
X plus 24. 32.
Okay, good.
Minus 15.
By minus 15.
No, no, plus.
Okay.
Because squared minus 24 minus 7. Negative 16.
Negative 16 exactly. Okay, so these are
Done.
no, no, you're not done. These are two slopes that we were looking for. Okay, we have to find the equation, um, which is y minus y1 equals to m into x minus x1, right? If we take x1 as negative 1, you will get a different y1. If you take x1 to be 1, you will get different y1, right? You still have to calculate y1 and y1 for when x is 1 and y1 when x is negative 1. Okay, so then you have to substitute those values, their corresponding slopes. Okay, then you will be able to get the equation. Are you getting my point? You're,
Yeah.
yeah, so please try to calculate that.
So I take x1 as 1.
Okay,
And then y1. We don't know the y.
you can calculate what is y1. Y1 is the functional value at 1. Oh,
We don't have the c. Yes, we do.
no. It is the functional
No,
value.
I'm
No?
just trying to do. Yeah.
So in your parent function, you just have to substitute x with 1.
Oh, yes. Uh, 32.
Or is 32? Is it?
Yeah, because we put a 1 in the parent function, no? N is not 32. This is why.
How can you say that it is 32? It is m, Neha. It is m. This is not your parent function. This is a function that will give you the slope. You will
The
get
parent function is that.
is this one. Yeah, is that one.
Okay.
Yeah, substitute x is equals to 1 in this.
I plus 12 minus 7. Okay.
5 plus 12 minus 7.
10.
10. Right? So the y1 is 10. Okay. Yeah, simplify it. Is it 42?
Oh, no, no. 22.
Okay. Now for the other value.
Minus 5 plus 12 plus 7. 14.
Is it correct? Is it true? Why you for
It's true.
why you forget to multiply 16 with x?
Oh,
Not positive 16, it's negative 16. Okay. Now you can see that this is the equation of tangent. Means the function that we were getting, for example, whatever it is. So this is the equation at this point. Now you can see it is linear. And the equation at that point is also linear, right? I think
yeah.
whatever is the graph of the function. So they are linear. What the first derivative was, it provides us, uh, it models the slope of the entire function. Okay, and by just substituting the domain values we can get the slope at that particular value. As you can see, at 1 you were getting the slope 32, and at negative 1 you were getting the slope negative 16. So you can see there is a difference of trend too. At negative 1 the function is decreasing, at positive 1 the function is increasing, right?
Yeah.
Okay, all right. So let's try to solve question number 5 now. Please try to solve it here.
Okay.
Yeah, this place on the left of the page. Did you read the question?
It's the same concept, sir. They give
No?
us a function, give a
Mhm.
gradient. Oh, they give us a gradient of the
Yes.
tangent. N
Yes.
equals to 2. Okay.
So what does it mean?
So instead of a point, we have,
Gradient now, right? And
yeah,
we have to find the equation of tangent,
That. Yeah.
right? So why you are taking the
This is
derivative
the
now?
derivative.
No, no. Now my question is, why you took the derivative?
So that we can do the y equals to mx, y 1
No, you
minus
are
y
no,
2
no.
formula.
What was our purpose when we were using this derivative, right? After getting the derivative, we were just substituting a value in it to get the slope. We are already given with the slope. Then why you are using the derivative now?
Okay, so I don't need to do this. So I
You
just
need
use
to
the
do
parent
no,
function.
no. You need to do this. You need to do this. Even if your derivative is wrong.
Okay.
First correct your derivative.
Why is it wrong? Or positive.
Still wrong.
Now it's correct. Huh?
What is the derivative of x cubed?
3x squared.
Okay. Now they said the function. Um, you haven't any idea at which point you have to calculate. Uh, you have to make the tangent, right? They provided you with
Yeah.
the gradient. So if you equate it to equals to 2, and now you can solve it for x, solve this equation for x, and then you will get those points at which the gradient is 2, and for all those points you have to find the corresponding tangent equation. Yeah, please keep the
Yeah,
equality
I'm
in your
following,
mind.
sir.
Wait, please keep
Hmm?
the equality in your mind. It will become equals to 0.
Yes.
Okay, so these are the 2 points at which the gradient is 0. Oh, sorry, the gradient
Yes.
is 3, right? Okay, then what to do further?
Now
What
we
you
need to use that formula, put the m and x in, and try
what
to
is
find the y.
but no, by putting m and x you can't find y. At these points you have to find the corresponding functional values. Okay, so in the parent function you will substitute x equals to 3 first, and then after that you will substitute x is equals to 1 over 3, okay, to get
No,
that point y1.
I substitute x value in the parent function to find y.
Yeah, to find y1, huh? Because in your equation y minus y1, this is the value of the parent function at this x1. So you just
Okay.
find the x1s. There are 2 points, 1 and 3 and 1 over 3. As you did in your previous question, you were given with positive and negative 1. Now you are having 3 and 1 over 3. So substitute them, calculate the corresponding y values. This is at what point?
Uh, 3.
Okay, and now for the other point.
It's on the calculator. Processing. Okay. Weird number. 77. Oh, 77 over 27.
When I calculated, it is not 77 over. Okay, it's negative 77. Okay, now make the equations.
Okay. for this, weird numbers. But that's the function, sir.
95 over.
It's 27.
Did you work that?
Yes.
Let's see. Okay.
My internet's connect off. Yeah, it's okay.
Okay. Scroll down, please. Scroll down to question number.
7. No, 6.
Yeah. Read question number 6. First, you have to explain that
Find
question.
the coordinates. Okay, find the coordinates of the point where the normal to the graph of that function at x equals to 1 intersects the curve again.
Can you make it geometry?
Weird question, but I kind of understand what it wants. My tablet lost internet, sir. So I'm trying to draw with my cursor. Okay, so this happens to be something like this. And then at x equals to 1, it's over here.
That would be your tangent line, right?
Yes.
Okay, but the question is not about the tangent.
It's about when the normal will intersect that line again. Over here.
So what you have to do, I think now you have to tell me your plan to solve the question.
So first find the derivative and the tangent formula,
Why
and
tangent?
then find
Why tangent?
not the tangent formula, the tangent's gradient, and then find the
No, no.
normal's gradient with the tangent's gradient,
Okay,
and find the normal's line
okay.
along the tangent's line, and
There is no need to
substitute
get.
it in the
There is no
parent
need to get.
function.
There is no need to get the normal line. There is need to get only normal line, not tangent line.
Oh, okay. And then
Okay.
substitute that, oh, yeah, substitute that function into the tangent function, and
Why?
then you get
Why
this.
into the tangent function? Basically, what is the question? The question is very clear.
No,
You
no,
have to
substitute
find.
one. Yeah, substitute
You have to
one.
find where
Oh,
these two curves intersect. Okay, where this curve and this curve they intersect. Okay, this is the tangent. So when two lines intersect, how we can find that? It is the intersection of a quadratic function or a quadratic equation to a linear equation. So simply what you have to do, You will
Find the roots.
you will equate them.
Oh, yeah, equate.
Make it equals to the equation of normal. Okay.
I don't quite understand this question.
No, no, this is the hierarchy. You just have at the end, you have to equate function with the equation of the normal. You will get the values of x. Okay. At those values of x, you have to find the corresponding functional values. So you will get the order pair. You will get these order pairs. Okay. So, but you will understand it. But before that, you need to find the equation of the normal first. So let's start finding the equation of the normal.
Okay.
To find the
I thought
equation of
that
the
before it. Okay.
normal, what you need?
Gradient. I
Gradient
need
of
to
the
find the
normal.
gradient.
Yeah, the slope of the normal. Okay, please start your work.
Yes. Oh my God, my
Should I solve if you have any problem with your?
yes, I have problem with internet. Yeah. Please
Okay,
do it, sir.
okay. So we are given with the function f of x is equals to x squared minus 3x plus 1. Okay. What first I have to do? I have to calculate its derivative, which is 2x minus 2. So 2x minus 3. Okay. Then to find the slope of tangent, I will substitute, I will calculate f prime of x, and I have to check it at 1. I will replace it with 1, so it is 2 times of 1 minus 3, which is negative 1, right?
Yeah.
Then slope of normal, it would be negative reciprocal of this, which is 1. Got it? Is it clear?
Okay, got it.
Yeah,
Yeah.
and then to find the value y1, I have to calculate f of 1, the functional value at 1, so it is 1 minus 3 plus 1, which is negative 1. Is it clear too?
Yeah.
So my corresponding point is 1 negative 1 and slope is 1. So my equation of normal, it is y minus y1 in journal into m into x minus x1. The value of y1 was negative 1 into m is 1, so x minus x1 was 1. So it is y plus 1 equals to x minus 1. So y equals to x minus 2. Is it clear? This is
Yeah.
the equation of normal, right? And now I have to find the intersection point, so I will equate it with the parent function. So x minus 2 at the point where they both becomes equal, no? Means the quadratic function and this line, when their intersection point is basically the point where they both becomes equal. Okay,
Yeah.
so by keeping that in mathematics in my mind, I have to equate it with that one. So x square minus 3x plus 1, which is um, x squared minus 4x plus 3, right? And the
Yeah.
factors will become x minus 1 and x minus 3. So I will get x is equals to 1 and or x is equals to 3, 1 and 3. Okay, is it clear? So 1 and 3 is the point, is the these are the values of x at which the function will intersect to the parent function. Okay, so I already calculated there it's the point for 1 because it was in the question, and when I calculated its functional value at 1, oh sorry, the slope at 1, so basically I found that point. All right, so one point was 1, -1. Is it clear?
Yeah.
And for the other value, I have to substitute 3 in my parent function, and f of 3, it will become 3 square is 9 minus 9 plus 1, which is 1. So the second point is 3, comma 1. Clear? So this is a point where the tangent to the curve will intersect to the equation. Got it?
Yeah.
Okay. Look at question number 7. In question number 7, it says that find the equations, the tangent of this function that are normal to the line. What does this mean now? You just have to explain me the question. I will solve it.
Now that we have the line of the normal.
We
Oh,
haven't.
no, 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 no. No, we learned that the tangent. Wait.
Find the equations of the tangents of this function that are normal to the line.
So this is like 1 by tangent because it's normal to that function. So the tangent would be like 90 degrees. I think I understand, sir, but then I can't explain it properly. Hello?
Okay, what will be the steps that I have to follow?
Now I have to use the normal line and turn it into tangent line. Just use the, wait, I just,
Wait, the question is very clear. We have to find the equations of the tangent of this function.
yeah, this is the normal.
No, this
And now find,
we have to find its equations of the tangent. Okay, but there is a condition that those tangents will be normal on this. What does that mean? This is a linear equation. If I just simplify this, it is x plus 2y plus 5 equals to 0. I can write 2y equals to negative x, negative 5, and further I can write x is equals to negative 1 over 2x and negative 5 over 2, right?
yeah.
Okay, so the slope of its tangent of this curve is negative 1 over 2. Okay, but we have to find the tangents of this function that are normal to this. So what will be the slope of its normal? It is negative reciprocal of this one,
Yes,
which is 2.
yes. Negative reciprocal. I forgot the word.
Is it clear? Now, this question is
Yeah,
quite similar to this one, question number 5, in which we were given with the function and we are given with the gradient. We calculated the gradient from the normal of this, and then we have to equate the derivative to the gradient. Then we will find the values of x, and from those corresponding values of x, we have to find the corresponding tangent equations. Okay. So the given function is f of x is uh, x cubed plus x squared plus x minus 1, and its derivative will become 3x square plus 2x plus 1, right? Is
yeah,
it clear? Okay. Then I have to equate it with 2. Got it?
yeah,
Okay. Then from this I will get 0 equals to 3x square plus 2x minus 1. Is it clear?
yeah,
So its factor will be negative 1, negative 3. So they would be x minus 1 and 3x minus 1. No, minus 1 times negative 1 will become positive. So it is okay. So 3x square, 3x minus x is 2x. And yeah, these are the factors. So I will get x equals to negative 1 and x is equals to 1 over 3. Got it? So these are the values
yeah,
of x. So from those corresponding values, I have to get their functional values. So f of negative 1 is basically negative 1 square will become positive 1 minus 2 plus 1, which is 2, right?
yeah,
Negative 1 square is 1 minus 2. Oh, sorry, not in this one, in the parent function. That is derivative. Okay, negative 1 cube is negative 1 plus 1, negative 1, negative 1. So it will become, it is negative 2. Okay, I accidentally substituted in the derivative form. Okay, at 1 over 3, it is 1 over 3 cube, which is 1 over 27 plus 1 over 9 plus 1 over 3 minus 1. And if I calculate this, it is negative 14 over 27. Okay, so my equations will be y minus y1, okay, that is equals to m into x minus x1. So y plus 2 equals to 2x plus 1, right? Oh, sorry, plus 2.
yeah,
So it will become y equals to 2x. This is one equation. And the second equation will be y minus y1, which is negative 14 by 27, and that is equals to m. M is uh, 2, x minus x1 is 1 over 3. So right side will become 2x minus 2 over 3 equals to y plus 14 by 27. So by simplification, I will get 2x minus 32 by 27. So this is the second equation. So these are the equations of the tangents that are normal to the previous equation. Is it clear?
Yeah.
Any question?
No.